Hi, I'm Vijay Velasamy. I'm a senior director at Comcast, working on the X1 platform. My talk would be grow slow, go big. I'll be talking about our experiences with the X1 platform, the challenges that are faced with it, and how we are going to be using Scylla to solve some of the challenges associated with it. Hello, everyone. My talk's going to be about grow slow, go big. It's a bit surreal that we are located in a place not too far from a big database vendor outside. First, I'll talk about the X1 platform, some of the challenges that we have been solving and looking to solve with respect to the technology behind it, and talk about how also we are looking at how we can use Scylla to solve some of these problems associated with it, and what are our experiences with it, what are our learnings from it, and how we look to evolve along with Scylla. So the X1 Xfinity platform is basically the flagship video platform for Comcast. Took some time for this to start playing. It is a Emmy award-winning technology around the voice-related control, where you can talk to your remote and you can say what you want to watch or what can I watch, and then there are user experiences to find what you want to watch quickly and then be able to watch what you wanted to watch. There's places you can search for what you are looking for, you can look at what you have been watching and similarly continue what you're watching on this platform. There are about over 13 million customers actively on the X1 platform. More than 29 million devices that we cater to from a background perspective, data stored in private public cloud facilities. So examples of what we are looking to do with databases and how we use from a feature standpoint. If you say last watch on the X1 remote, this is what comes up. Typically, when you press the last button on your TV remotes, you go back to the last channel that you're watching. In the case of the X1 platform, what we did was we could surface 9 of the last watched video assets, ranging from linear channels to video on demand to DVR assets, and be able to find what you were watching and continue watching. If you had toddlers in my family, they are fascinated with the remote, keep pressing all the buttons they can. Typically, that means they are pressing the channel buttons up, down, keeps changing the channels. They're fascinated by the whole experience that they're able to control something with what they're pressing, which is what we do, right? So, but once you pull the remote back from them, we want to get back to what we were watching. So this is a feature that's very popular among customers, where they are able to press last, go back to what you were watching without trying to remember what channel is National Geographic on or what channel CNN is on. We have seen scale. So peak requests about 1.5 million requests per minute. Mostly, if you think of it from a database standpoint, these are most operations are writes. Every channel tune, every tune event for an on-demand asset or a DVR asset is basically populated into this data store. And then when someone presses the last button is when this is being surfaced. So from that standpoint, we have a lot of writes, about 85% writes over the course of the day, and 15% reads for this service. Again, around the guide experience, we have a lot of badging around how we surface what program you've already watched, what are new assets, or some things that you can watch. The other place where we are looking at is resume points. Resume points are very popular as well among users. When you're watching an on-demand asset or a video recording, there are offsets that are being recorded periodically so that when you stop watching it, you can resume playback of that asset. In this case, it's from any device on the household account. So it's the main theme behind the X1 platform is watch video your way, anywhere, anyway. So if you are watching on one device, you can always continue watching from another device on that account. The other thing associated with this, if you see the watched badge, there is also the notion that if you have watched a significant portion of these assets, basically you would like to know what you watched and how far you watched, and be able to go back and continue what you wanted to watch. Similarly, parental control pins are huge. Lots of people set parental control pins, and also settings related to how the TV is being used on that particular place. So that's the kind of challenges from a feature standpoint. But from a traffic challenge, there are different challenges that we experience. So if we look at viewing behavior, there are different viewing from a daily perspective. I mean, there is the top of the hour and the bottom of the hour where most channel changes or tunes happen, which is when the most programs begin or end. So if you looked at the last watch program service, lots of reads happen during that time. Similarly, there are heavy workloads during different days of the week as well. Weekends are more popular for viewing some of the recordings on demand and linear. I'm sure today will be one of the other peak viewing for today's evening. Lots of people will be tuned to their television screens, but at least they won't be changing channels because they're looking at the news. Other challenges, infrastructure and maintenance. So we design for resiliency, where we are able to withstand some amount of failures in the subsystem. So even if there are issues with infrastructure, compute, network, firewalls, data centers, there is a level of resiliency in the services, and we are able to surface what the user is looking to do. And that doesn't just stop at infrastructure in the data centers. There is also the nationwide fiber that has an impact on how we deliver the technology. So in terms of that, there are national events that have an implication on some of the back-end infrastructure. For instance, there was a couple of weeks ago, the nationwide emergency alert system test that was scheduled at 2 o'clock means that everyone of those 29 million devices gets the same emergency alert system across the nation. Everyone stops watching video at that time, and then after the alert system comes in place, there is tunes that happen to make the people continue watching what they were watching. So all this has implications on how we solve for the technology that we use. So there was one interesting case that we wanted to use Scylla for, so where we had an internal data store that we had lots of heavy writes every day, keeps populating data, and so very low read volume in general, but there are spikes for various reasons. So in this case, what we wanted to achieve was consistency, or being able to read the data when we wanted to from that data service, even though it's a low read scenario in general. So what we came up with was keeping it simple. We had a cache in front of the data store, which was HTTP caches. The data service is RESTful APIs connecting to a NoSQL data store. So the cache is, so all this infrastructure is replicated across data centers. So we wanted to keep the caches warmed in sense of even though the data is being populated to one data center, the data is available in other data centers. So that's easy with NoSQL technologies, that's what they do. But still, from a cache standpoint, we wanted that to be available as well. So we had a cache warmer that looked at all the reads or the writes volumes that happened, and basically replicated that all the data with reads being imposed on each and every data center that we had this framework in. It worked. It solved a lot of issues for us, so we kept running it until we had technologies that could solve it in different ways. And that's when Scylla was something that that interested us. So we got rid of the caches, had a simple framework where we had the data service connect directly to the Scylla database. What does that do? I mean, you don't have the same level of complexity in the system. The performance is much more simpler, performance higher, and the deployments are simpler. So transitioning was one thing that we are always, migration in some sense, is an important aspect. We have all our systems in production, although we have the ability to have some staging environments. We try to avoid the hot-cold environments. We always have hot-hot. So we looked at how to do these changes. In this use case, we could afford not doing any of the complex migrations. So we could just replicate the writes to both data centers and just switch over from one data center to the other. If you think about the last watch scenario that I was talking to earlier, the relevancy of the data is short, meaning as you populate data over a couple of days, the recency is also maintained with just a small amount of data. So when we look at using Scylla or transitioning to Scylla for that scenario, we could even just let it populate for a couple of days to both databases, and then just simply cut over the reads to the other data store. I believe I was talking to Dor earlier, and he said that there's another way we can do this with Spark. So I'm looking forward to some of the talks, and I believe there was a training session yesterday, if most of you attended. So Spark is the way we could migrate some of the data in production. So in this case, we just wrote to both data centers for data services or databases, duplicated the data, and threw away the old. So while we were trying some of these nuances with Scylla, not a lot of things that we learned, but at least certain things we wanted to keep in mind. These are things we jotted down so that it'll help us with future migrations. TCP settings are an important aspect, especially related to Keepalive settings in infrastructure across global or distributed data centers. Firewalls are very invasive in the sense that during low traffic, we saw connection timeouts in between the nodes even. So we needed to tune the Keepalive settings so the firewalls don't drop those connections. The data keeps replicating, and we have solved that. With the newer instance types of I3.8s, we needed to keep in mind some of these settings that were used internally. We'll be happy to share some of those in some form later on, but keep in mind that any new instance type you move to needs some level of fine-tuning of those OS parameters. Security and default user, we tried not to use the default user, so we changed the default user that Scylla runs on. Also, ulimits, keep in mind that the nprocs, no files, all the limits are set to be able to handle the heavy workloads. The defaults that come with any Linux distribution are always low enough that in production they'll cause some havoc. Default memory allocated, so when we ran some of the node tools and other things with some of our with the Scylla clusters, we noticed some timeouts and some issues. So when we adjusted the default memory allocated to Scylla, those issues were resolved. We use Grafana that comes with the enterprise version to do our monitoring. Ansible is the tool that we use to deploy the Scylla cluster and do the maintenance. When we were evaluating the Scylla open source framework, we had some issues with running repairs, especially with the secure framework that we were deployed with. The enterprise, we reached out to the Scylla folks. They came back with identifying issues that they had fixed with the enterprise versions. We moved on to the enterprise versions, and we didn't see those issues anymore. To give you an example of the performance improvements we had, so this is data from a couple of months ago where we are doing test at scale. The right side has the scale of operations that were performed. So we typically test the same scale of workloads that we have in production. So and even scale it beyond what we traditionally see with other data stores. So with doubling the number of requests that we were processing with Cassandra and doing the scale test, we were able to achieve 10x performance improvements with Scylla. So which is like very important for us. We could scale down in terms of how much we were deployed with Cassandra and make those gain from those advantages. So what would we gain? I mean, in this case, we were looking to simplify the deployments, no more caches, no more cache warmers, trying to make sure that the cache warmer was keeping up with all the writes to do the reads across multiple data centers, making sure that it finished before times of peak load, so that we didn't need to address any other resource constraints, and so simplifying the deployments. Also, in terms of the hosts that we were using with Scylla, the number of hosts reduced, so compared to the Cassandra instances that we were using, so lesser number of nodes to deploy to. So that's reduced infrastructure, and we gained 10x performance improvements. I mean, much more than we were expecting even in this case. Famous French poet Moliere mentioned trees that are slow to grow bear the best fruits. So that's something that we've been working on from the X1 perspective as well. We've grown over the 8 years from 0 customers to over 13 million accounts on the X1 platform. We've been evolving our technologies to handle the scale, and similarly, we are looking to grow with the how we adopt Scylla in various use cases that we have. And I'm sure it is the same for a company like Scylla. They have been growing slow, but they are going to go big. Thank you.